So today what we're going to do is we're going to study normal sampling and modeling, right? We want to know if you can explain normal sampling, modeling, and then the key idea is to apply what we've known. And what we learned in the previous lesson, which is n of mu sigma squared, okay? Or n of x s squared. Now, this is applied to large studies or research that we have that we see online. Now, because they are very large, these large studies are just expected to be normally distributed. Now, sometimes you might have stuff where you have a skew to the left, a skew to the right, or your information is bimodal, but a lot of times that means that you're actually sampling two separate pieces of data, and you can basically pull that stuff apart with a little bit of analysis like we did in our previous unit. So in essence, this use of the normal distribution is a very powerful method, right? It's very powerful because this gives us the ability to predict and plan what we do in certain situations. When we assume that we have a normal distribution for real world problems, this allows us to make predictions and possibly adjust what we are doing in a business, in your school, in your studies, in population. That's it, really. So let's talk about the application. So for application, this is actually applied in many different disciplines. And it's applied in those disciplines so that these disciplines can adjust, we can make predictions of the future, and we can literally make money based on our choices from the normal distribution. Okay? So now, here are some examples of where it is used. So when we do this, we're assuming a normal distribution. We said that, and we can use this in manufacturing. We can use it in the sciences to postulate hypothesis. Okay. We can also use it for electronics, because if you think about it, they make millions of transistors, phones, everything, right? We also can use it for population studies. And those population studies are usually done by the government, big business. Because these two entities are looking to maximize the use of resources or maximize the use of the money that they have within a population. Okay. We also have psychological studies. As well. Now, those psychological studies could be looking at the reason why certain people eat certain types of food or are ill, or where certain populations have a propensity to have different diseases compared to other populations. Why that is can be literally looked at. So we're literally going to go and look at 2 examples. All right, let's go. So here's our first example. So this problem says the chart below shows an annual return on investment over the last 20 years. And if you're considering investing in the mutual fund, answer the following to help you decide whether you need to invest or not. So the first thing that we have to do is we have to go and calculate the mean and the standard deviation for this set of information and SD. And we're going to use, if we ever do this, we're going to use our spreadsheets to calculate that. Okay. Now, this overall is what we call an economics type problem. Okay. Now, these economics problems are based on money, and that's one of the things that we're always looking to maximize, right? So if we can find the mean and the standard deviation, then we could figure out what the possibility of getting, say, at least 9% return and when it's negative, right? So when we don't want to be actually, what would you call it, invested in this company. And this is one of the key concepts that we would literally. So when you go and take all this information and put in the year and return of all of this, you end up finding that for A, the mean, X bar, is equal to 10.6, and the standard deviation is actually 10.5. So now we've got A done. Let's take a look at B. So now we're assuming that this is a normal distribution, okay? And we need to determine the probability that the return is going to be at least 9%. Now, when we assume that this thing is a normal distribution, right, we're going to say that X is N of 10.6 comma 10.5 squared. So we're saying that it's normally distributed in this fashion based on the mean of 10.6 and the standard deviation of 10.5. So for the first problem, it says we need our return to be at least 9%. So what we're going to be using is we're going to be using our Z-scores, again, tables, and we're literally going to figure out when the probability of X is greater than or equal to 9%. And from here, we're going to have to take a time and use our Z-score tables to find what we're looking for. And in order to find our Z-score, we literally have to take our time and say Z is equal to X minus X bar divided by S. We do our calculations and we get the following. So we have 9 minus, our value is 9 minus the mu, which is 10.6, not mu, but mean, 10.6 divided by 10.5. And we end up with our Z-score being approximately negative 0.15. So when we do that, if we were actually looking at the normal distribution, what you would have is something that looks like this. Here's where we are. This spot here in the middle represents the mean, okay? Where the mean would be 10.6. And what we're looking for is, think about it, our 9 value. Now, remember, when we use the Z-score table, we always end up with the values up to and including 9. So in order to get everything that is in this black shaded region, we literally have to do 1 minus the probability of our z value being less than or equal to not 9, but negative 0.15. And that will give us what we're looking for to get this portion of our graph. So now in black, here is what we have. So P of x greater than or equal to 9 is equal to P of z being greater than or equal to, well, negative 0.15. To actually get that, we literally have to take 1 minus P of z being less than negative 0.15, which is what we use our z-score tables for. Now, let's go and take a look at our z-score tables. So imagine that we have to find our z-score table of negative 0.15. So what we'll have to do is we'll have to go over, we find our 0.1. Then what we're going to do is we're going to go in and we're going to go all the way across to the point where we have our value. And in this case, our value for z is going to be this value here of 0.4443. So we have 1 minus 0.4443, which gives us this final, and it gives us our final answer of 0.5557. So to answer the first part of our problem, which was give a return of 9% at least, we can say this. We can say that we're going to get about a 56% chance of getting 9% return. So let's write that out. So basically, the probability of getting at least a 9% return is about 56%. So the next part of the problem asks us, what would happen? We're always worried about this. When you get older and you have an investment, you're always worried about what would happen if you got a negative return on your investment, i.e., we actually lost money. Okay, and that happens all the time when you have investments. Sometimes it grows and sometimes your investment shrinks, but overall, throughout the life of your investment, you want it to be a net positive gain every year or overall. Okay, but now we're always worried about having a negative return. So what we're going to do is we're going to figure out where the negative returns occur with our problems. So when we're talking about our random variable, so for B, when we're talking about a negative return, we're actually talking about x being less than 0. So what we want is the probability of x being less than 0. And that only occurs when we calculate our z-score, because we need to translate this into a z-score. So you go z is equal to x minus x bar divided by s. X is 0 minus the mean of 10.6 divided by, oh boy, divided by 10.5. And we do our calculation. And we end up with a z value of negative 1.01. Now, since we have that, what we're actually looking for graphically is this. We've got our normal curve that kind of does this, right? And what we're actually looking for is the probability of Z being less than negative 1.01. And what that's actually making us look for is what we find on our Z-score table, which is everything that is less than that value. So let's go to our Z-score table and find Z of negative 1.01. So basically what we have here is our Z table. So we're going to look for our Z table. We're going to look for the intersection of this column here. Oh, no, this column here. And this column here and 1.01. So this row here. And then we've got our value that we have chosen here, and it's 0.1562. And since we've got the 0.1562, this tells us that the probability of having a negative return is 15.7% or 16%. Now, that's pretty good odds that 84% of the time you're always going to get positive returns with your investment. And so now let's go on to, let's make sure that we call this part 2 of our problem. And then we'll go on to our next problem of the day. So if you look at it, it says here, we need to determine the probability of investment will have a return greater than 6%. And then we have to say what assumptions are necessary for your answer. Okay? All right. So, well, one of the assumptions is that we're looking for the probability of X being greater than 6. So here's what we have to do right now. We have to calculate our Z-score. So our Z-score is calculated like this. Z is equal to X minus X bar divided by S. Punch in your 6. You got 6 minus 10.6 divided by 10.5, which gives us a Z-score of negative 0.4381. And this means that our probability of our Z-score being greater than negative 0.4381. Now, you need to remember that our Z-scores always have to be less than. So we're going to say this is the probability. So this is going to be 1 minus the probability of our Z-score being less than negative 0.4381. And so now we're going to go to our table again. So for the Z-score corresponding to 0.0 less than 0.44, we're going to use this column here, the 5 column, all the way down, and then we're going to use our column, our row here, and we use the intersection to find what we're looking for. In this case, our Z-score gives us, our Z-score is going to be negative 0.3264. No, negative 0.3264. And we have 1 minus 0.3264, which gives us the following answer. So what this tells us is the following. Therefore, there's a 67% chance of making more than 6% on your investment. All right, so now let's talk about the assumptions that are made. And here are your basic assumptions. We're saying that X is a normal distribution. And we assume that the economy is consistent, and i.e. we have some really good times. Basically, if you think about it, as long as we don't have a lot of crazy stuff like a natural disaster or the stock market crash of the century, then all of these calculations are completely valid. So for our next example, we have a survey that asks city kids on a scale of 1 to 5, 1 being not safe and 5 being very safe, rank how they feel about attending their school. The mean response was 3.9. Okay, so that means our mean was equal to 3.9 and the standard deviation was 0.65. Answer the following, okay? Determine the probability that somebody answered with a 4. So as usual, we're going to assume that this is a normally distributed set, okay? And now we need to determine the probability of somebody answering with a 4. So the probability of X is equal to 4 is going to be calculated this. We're literally looking for the middle. So here's what we're going to do. We're going to go and find the probability of X being 4.5 minus the probability of 3.5. So the key idea is this. You've got your normally distributed curve, and we are looking for the number 4, right? And what's happening is we've got something going on here, and we have 4.5 above, which gives us everything underneath this portion of the curve. And then what we're going to do is we're going to go and chop off the bottom half of 3.5. So we get this nice little sliver in the middle here. Okay. So we get this nice little sliver that I'm going to color in black, which represents our value of actually X being 4. So when using your Z-score table, you're going to get the following Z-scores. You're going to get 4.5 equaling 0.8212. And then you're going to subtract it from the Z-score for being less than negative 0.62, which ends up being 0.2514. And that's going to give us an answer of approximately 0.5698. Okay, so then you'd say, therefore, the probability of selecting a 4 is 57%. And we're done. Now, let's go and take a look at what happens when we're trying to determine the probability that somebody answered with at least a 4. So just like before, when we were calculating our probability of X being greater than a certain thing in the previous lesson, here's what we did. We said the probability of X being greater than, it says at least 4. So greater than or equal to 4 is. So we're going to use our boundaries that we used before in our original problem. Remember that when we said we were looking at the answer of 4, we used the boundary of 3.5 to kind of include 4. So here's what we're going to do. We're going to say, we're going to look for the probability of X being greater than or greater than 3.5. All right. Now, since we're looking for X being greater than 3.5, we need to calculate a Z-score. Now that Z score is going to be Z is equal to, well, X minus X bar over S, which is going to give us this. So we've got 3.5 minus 3.9 divided by 0.65, which gives us approximately 0.62, which gives us a Z score of 0.62 negative, okay? So now this problem turns into this, the probability of Z being greater than negative 0.62, which means we have 1 minus the probability of Z being less than negative 0.62. And we do the rest of our calculation. So now we end up with 1 minus, take a look at your Z score table. You've got 0.2514 for being less than negative 0.62. And then that gives you an answer of about 0.7586, which means, therefore, there's a 75% chance of picking at least a 4. Now let's go back and let's take a look at our second last question. So we need to make sure that we can interpret the results from A and B. So let's interpret those results. So let's zoom out and look at those two results. So the reason why these two results are different is, so for the first one, we want only a 4. For the first question. Okay, now the reason why the next question is bigger, the second probability is bigger, because we are looking for a 4 or a 5. All right, so now let's go and take a look at our question here. Determine the probability of somebody answered a 2 or less. So to do this next one here, D, we're looking for the probability of X being less than or equal to 2. So really what we're looking for is the following. So now we're looking for something where we have a 2 or less. Now, here's what I want you to recall. I want you to recall this. The numbers are 1 to 5, right? So what we're looking for is a range. So we want a range that includes 1. So we're looking for 0.5 all the way up to and including 2. So we'll go to 2.5, just like what we were doing before. So what I'm going to leave you to do is I'm going to leave you to do this problem on your own, where you're going to calculate the following: the probability of 2.5, X being 2.5, minus the probability of X being less than 0.5. Do your calculations and you'll get the answer that we're looking for. Okay, and that's it. probability is going to be really low. It's going to be less than 2%. If you got less than 2%, then you are good. All right, I'm done. Your homework, I'm not going to do E, but your homework is questions number 439, 1 to 3, 9, and 10. And you'll have a journal for this to hand in at the end of the day. Now remember to calculate your Z-scores, and then once you've calculated your Z-scores, use the table to find the information that we're looking for. Message me if you'd like me to go over this with you, and we'll do the Z-score calculations. Now, the only thing is, based on the Z-score table, if you have numbers that are less than negative 3.4, your probability is a 0. So don't worry if you have something big less than negative 3.4. That essentially is a 0. So just put 0 if you have to.